Class 7, Science Chapter 13, Motion and Time. Animated Science. Introduction. There are many objects around us that move around. They change their position from one place to the other. A bird in the sky, a dog running, a man walking, and a car moving along the road are continuously changing their position from one place to the other. Such bodies are said to be in motion. Motion. Motion is defined as some kind of a change in the position of an object with time. There are three kinds of motion: rectilinear motion, circular motion, periodic motion. Rectilinear motion. Motion in a straight line is called rectilinear motion. For example, car on a straight road, march past of soldiers in a parade, and stone falling from a height. Circular motion. A motion in which an object moves in circles such that its distance from a fixed point remains the same. For example, blades of a moving fan, giant wheel movement, and movement of the planets around the sun. Periodic motion. A to and fro motion that repeats itself after a period of time is called periodic motion. For example, motion of a pendulum, motion of a child on the swing, branch of a tree moving to and fro. Speed. Speed is defined as the distance covered by an object in a unit time. For example, when we say that a car is moving with a speed of 50 kilometers per hour, it means that the total distance covered by it in 1 hour is 50 kilometers. For example, imagine that you have gone to see off your friend at the bus stand. Suppose you start pedaling your bicycle at the same time as the bus begins to move. The distance covered by you after 5 minutes would be much smaller than that covered by the bus. We can say that the bus is moving faster than the bicycle. In a 100-meter race, it is easy to decide whose speed is the highest. One who takes shortest time to cover the distance of 100 meters has the highest speed. Speed can be calculated as the total distance covered by an object divided by the total time taken. Hence, speed is equal to total distance covered divided by total time taken. When a body is moving at a constant speed, it is said to be in uniform motion. When a body keeps changing its speed while moving along a straight line, it is said to have non-uniform motion. Measurement of speed. Let us take the example of a ball moving along the ground. To measure the speed of the moving ball, we first draw a straight line with chalk. Then we roll a ball along the ground in a direction perpendicular to the line. Note the time at the movement the ball crosses the line and also when it comes to rest. The distance between the point at which the ball crosses the line and the point where it comes to a rest is measured with a measuring tape. Suppose this distance is 8 meters and the time taken by the ball to cover this distance is 4 seconds. Therefore, speed of a moving object, that is, a ball, can be measured as follows. Speed is equal to distance moved by the object divided by time taken by the object in meters per second is equal to 8 meters divided by 4 seconds. That is 2 meters per second. Therefore, the speed of a moving ball is 2 meters per second. Since the speed is distance divided by time, the SI unit of speed is meter per second and its symbol is m divided by s. The distance moved by an object in a given time can be measured as distance covered is equal to speed into time. You can also measure the time an object would take to cover a distance while moving at a given speed, as time taken is equal to distance divided by speed. Device to measure the speed of a moving object. You might have seen a meter fitted on top of a scooter or motorcycles and on the dashboards of cars, buses and other vehicles. This meter indicates the speed of a moving vehicle. It is called a speedometer. It indicates the speed of a vehicle in kilometers per hour or km per h. There is also another meter that measures the distance moved by the vehicle. This meter is known as an odometer. Our ancestors noticed that many events in nature repeat themselves after definite intervals of time. For example, they found that the sun rises every day in the morning. The time between one sunrise and the next was called a day. Similarly, a month was measured from one new moon to the next. A year was fixed as the time taken by the earth to complete one revolution of the sun. Often, we need to measure intervals of time which are much shorter than a day. Nowadays, clocks or watches are perhaps the most common time measuring devices. The SI unit of time is a second. Its symbol is S. Larger units of time are minutes or MIN and hours or H. All of them make use of some periodic motion to measure time. Motion of a simple pendulum. One of the most well-known periodic motions is that of a simple pendulum. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. The figure A shows the pendulum at rest in its mean position. When the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro, like in figure B. The to and fro motion of a simple pendulum is an example of a periodic or an oscillatory motion. The pendulum is said to have completed one oscillation when its bob, starting from its mean position O, moves to A, to B and back to O. The pendulum also completes one oscillation when its bob moves from one extreme position A to the other extreme position B and comes back to A. The time taken by the pendulum to complete one oscillation is called its time period. Let us suppose a simple pendulum takes 32 seconds to complete 20 oscillations. The time period of the pendulum will be time taken to complete 20 oscillations is equal to 32s. Time period of the pendulum is equal to number of oscillations divided by total time taken is equal to 32 divided by 20s is equal to 1.6s. Hence, the time period for this pendulum will be 1.6 seconds. Distance time graph. The distance time graph is a line graph which shows us how far an object has moved with time. Let us understand this with an example. While going to school on the school bus, you may note of the time taken by the bus to cover a distance from the starting point, that is, your home to the end point, that is, your school. You may keep the watch to learn about the distance covered by the bus after each minute from the odometer. Then the time taken and the distance covered by the bus is recorded as follows. This information is represented through a distance-time graph as follows. While drawing a graph, the following steps are taken. Number 1. A reference point or starting point O is taken towards left-hand margin on the lower side of the graph. Then, a horizontal axis OX can be taken as the representing time. Then, a vertical axis OY can be taken as representing distance. A scale is chosen to represent the distance and time on the graph. For the motion of the school bus, the scales can be time, 1 minute is equal to 1 centimeter. Distance, 1 kilometer is equal to 1 centimeter. For bigger distances, say 80 kilometers, you can keep the scales as 10 kilometers is equal to 1 centimeter. Mark values for the time and the distance on the respective axis according to the scale you have chosen. For the motion of the bus, mark the time 1 minute, 2 minute on the x-axis from the origin, O. Similarly, mark the distance 1 kilometer, 2 kilometer on the y-axis, as in figure 1.1. Now you have to mark the points on the graph paper to represent each set of values for distance and time. Observation recorded at serial number 1 in table 13.6 shows that at time 0 minutes, the distance moved is also 0. The point corresponding to this set of values on the graph will therefore be origin itself. After 1 minute, the car has moved a distance of 1 kilometer. To mark this set of values, look for the point that represents 1 minute on the x-axis. Draw a line parallel to the y-axis at this point. Then draw a line parallel to the x-axis from the point corresponding to distance 1 kilometer on the y-axis. The point where these two lines intersect represents this set of values on the graph 1.1. Similarly, mark on the graph paper the points corresponding to different sets of values. Figure 1.2 shows the set of points on the graph corresponding to positions of the bus at various times. Join all the points on the graph as shown in figure 1.2. It is a straight line. This is the distance-time graph for the motion of the bus. If the distance-time graph is a straight line, it indicates that the object is moving with a constant speed.